0 components checked out successfully. All right, you can use this. No, no. Type minus F. Access data files, no such file or directory. Yeah, no. This is okay, but this is an interesting kind of error I've not seen before. No. It's not. Research it later. But okay, so it's always interesting whenever you give tutorials to see what strange thing goes wrong that's never gone wrong before. But you do, each time you do some new things, and there's some learning that happens. All right, who has finished? We're now down to one person. Not even 2 people anymore. I know there were 2 people at one point. Nobody wants to admit they were the person who said they finished before? Okay.
What's the new subject?
How's yours going? Good. You're still getting the local change. Okay. Switch to account 29.
I have 29.
You have 29? You gave me 29. Okay, 28.
28, all right.
No,
You're joking, right? No? Okay, 27? Does anybody have 27? Okay, 27. Picking new ones without telling us is okay.
I'm 25 and 30.
You have 25 through 30. Thanks, yes. All right. All right, so what I'm going to do, right, is I'm just going to get started on the remainder of this. So if nothing else, you see what happens. So I'm going to, what SimFactory is going to do when you run code, it's going to put it in a directory called simulations, okay? And just sort of to make sure that we're in a fresh state and can do everything, we're going to remove that directory. Now, if you try to run 2 simulations with the same name, right, Cactus is going to block you. Okay, and so what I'm going to do is I'm now going to run this code with this name Hello World, and I'm going to use this Hello World par file that we looked at before. And when I run it and I scroll down, if I scroll down far enough, I will see the output of the code. Cactus tells you a lot of information about how it's going to do things. I will see Hello World printed about 10 times. Okay, and that's what that code does. That's all it does. It's just a basic, the most basic Cactus program you can have. Okay, and the idea here, create run, is going to create that simulation for you and run it. Make sense? All right. So the next thing after that, we have a running single star simulation, and hopefully we will get that to work for at least 5 people. It's done. How many people are done? Look at this. I've already hit my goal. Okay, so people who have finished your compiles, you should go and run the Hello World program, and then we're going to create this TOV simulation. So the TOV simulation, we're going to use a magic called write file. Okay, this needs 2% in front of it. It says write file and then the name. So you can use your Jupyter Notebook as kind of between the %load and % write file. You can use your Jupyter Notebook as a kind of a weird editor. Okay. So when I execute this cell, it will write out that parameter file, or overwrite it if it's already there. Let's just take a moment to look at what the parameter file looks like. All right, we take. We tell it which thorns we want to run, which thorns we're going to need, and you just say active thorns equal, and then you give the names. Then you have parameters that you give to the execution to tell it how to run. So termination condition is based on time, okay? And Cactus CCTK final time means 400. That means when the simulation hits 400 in the time units that it's using, it will stop. Okay? You can also have termination triggers like the ones that follow, which trigger after the code's been running 24 hours, or something like that. And all the other parameters are just whatever the thorn writer wanted to give you control over. Okay, there's just some parameter for it.
So is there a list being used for locally visible selection?
Yeah, so you may remember that over here, we ran we were in Cactus with -OB, and that listed, except I'm not in the window I thought I was in. EXE, Cactus, -OB, and that showed you all the parameters, which you should read very carefully before I risk.
Is there any method to how you wrote out the active forms of the other tab?
I mean, how this is organized?
Yeah, the very top tab, so.
So you typically, what people do is they put the active thorns at the top. And then usually the next thing that follows are directives to Cactus. But there's really, it can be in any order. Okay, and then usually the rest of them, they're grouped by thorn. So all the termination trigger ones are together. And this set of parameters is used for setting up the grid, right? It's going to be, it's going to use Cartesian grid 3D. It's going to set an x min, a y min, a z min, and an x y, and a z max. It's going to set dx and dy. I think that's pretty self-explanatory. But that's the basic structure. Does that make sense? Okay, all right, so now I'm gonna start this simulation. Now, this one is gonna work a little differently. So the command is already finished executing, but what it's really done is it just started the simulation. It just started a longer running execution, and it's running it in the background. If I want to see information about it, I can ask it to list simulations TOB, and it will show me that that simulation is active and running. Okay, so you notice the difference was I put create submit here instead of create run. Create submit is going to run it in the background. Now, the way SimFactory was written is it's supposed to know about the batch queue systems on a bunch of different supercomputers. So that if you log into some Exceed machine, for example, and you run this command, it's supposed to submit your job to the batch queue. If you run it on your laptop, it's supposed to just run it in the background, like with ampersand. It's the idea behind SimFactory is it abstracts away some of the details of the machine for you. Now this command is follow, and this shows you the output of the Cactus simulation in progress. And you can just watch that increment slowly as it continues to run. Okay? And it's just going by. And maybe you don't want to tie up your notebook if you're watching that output. So what you can do is you can make kernel interrupt. Okay, that will stop this cell from executing. But all this cell is doing is it's following the running execution. That running execution is still going on. If I go and I list simulations again, okay, I can see that one of them is finished and my hello world is finished and my TOBET is running. Now, if I wanted to, I could use SimFactory to stop the TOB execution. I don't want that to stop, so I commented out the command just so you didn't execute it accidentally, just like blindly executing all the cells. Question? No? Okay. I had another little thing in here, but I had another little bit of bash code. I don't know what happened to it. That was going to watch and tell me when this is finished. But in any event, I could just watch to see when this finishes in one of several ways, right? I could re-execute this follow. So I'm going to be around, obviously, for the rest of the workshop. If you keep playing with this and you have questions, you can let me know. Yes?
Mine's not sort of like running anything, and I don't know why.
Okay, well, let me take a look.
I think it's happened. So, yes, no, no one's running. I think like I'm not busy. No, no, you couldn't. Well, you couldn't. You don't know this. And we get.
But you did, you must, what you probably did is when you're scrolling, probably grab this thing and drag it
Oh,
up.
can you do that?
Yes. All right, let's see, how am I doing on my simulation? It's still running. We're officially in coffee break time, according to the schedule. Well, I did start a little late, so. Let's see how the machine load is coming. Only a load of 50. Doing great. There's insight. There's insight. All right, so what's going to happen next, right, after this finishes running, is we're going to plot the output. And that should happen just by executing these cells. What you will notice is there's a matplotlib inline magic. Are any of you familiar with matplotlib? Who's not familiar with matplotlib? How about that? One person, 2, 3 people. So matplotlib is a really, really nice plotting program that comes built into Python. And it integrates with NumPy and SciPy so that you can do, you can pull in files and read them and graph them in a whole bunch of different ways. It's at least as nice as GNUplot in my experience, if you use that. And it's got funny little things, quirky little things in it, like it's got an XKCD font, if you want your plots to look like XKCD cartoons. Any questions? Okay, so when you're reading in, NP is the NumPy library, and gen from text is your standard command in NumPy for reading in an ASCII formatted data file. And once you have it in there, you can pull out the columns and the rows, and you can plot them. As simply as calling this plot routine. In this case, we also put labels on them in a legend. But that's all you need to do to make a basic plot. How many people are running the simulation? Oh, excellent. Almost everybody. And nobody is leaving the room to get coffee. Yeah?
Those are the Einstein Toolkit thing work after the compilation, so they just shut the page down.
Oh, I see.
Yeah.
Yeah, it'll do that. It'll shoot the page over.
I tried like moving things around, and I'm like, I can't move the cell blocks. I don't know how to mess with them.
Well, you can, like, if you click on this one, say.
Oh, you can actually.
Yeah, well, I think you can drag it. You can try. And it's working. All right, so this is basically everything that you were supposed to see. Do you have any questions? Anybody have any questions?
Are these available online anywhere?
Yes, if you, in fact, you can ask, if you go onto the Einstein Toolkit.org site, you can ask to get access to a machine that will run the same tutorial, and you can play with it some more. So all this is available. Yes?
So, how easy would it be able to port over to something like Google Colabs?
To Google Go
Colabs.
Colabs. I haven't tried it. It shouldn't, if it can run a basic Linux image and allow you to install packages, it should be fine.
Yeah, I don't know what the limits are. They'll offer GPU and TPU for free.
Right. So Cactus does not make use of those things at the moment. But we'll use the TPUs for counting raised hands.
But is that something then that, if they study this and if you go to the site and study it, it should be obvious then what we need to do.
Right. So at the top of this document, we have instructions for how to install all the packages that you need. Right. And in principle, if what they're offering you is a Linux environment, that should tell you what you need to do to make that Linux environment work. When we, before we release the Einstein Toolkit, we test the build on a whole bunch of different Linuxes, Debian and Mint and Ubuntu and Fedora and so on. Who's up after me? Oh no, it's coffee break.